In this video, we're going to be talking about projectile motion. Okay, so if we look at this diagram here, we're following the flight path of a ball. So let's imagine that someone down here kicked the ball, and then it started moving up in this direction, and then eventually back down over here. So it's following a kind of a parabolic path. Okay. Now, there's a few key things about this motion that I want you to be familiar with. So the initial point at which we kicked it, so if we zoom in at this point here, so when the ball was first kicked, okay, so imagine that they have the ball, okay, and then there's someone who has come and kicked it. So there's a force kicking from this direction. So as soon as that ball is kicked, it's going to have a horizontal and a vertical velocity component. So that means that when we kick it, the ball is going to move like it has shown in this path, up in this way. But we can break that vector down into two parts, and that force into two parts. So there's actually going to be a vertical component, vertical velocity, and horizontal velocity. Now the terms we use to describe those two things is Vy and Vx. But if we're talking about initial velocity, then we actually use U. So Ux and Uy represents the initial vertical velocity and the initial horizontal velocity. Okay, so that's what we're talking about when we're looking at Ux and Uy. Now, Vy is the final velocity. So if we look at the point over here now, sorry, the point over the other end, over here, the velocity will still be there. So you'll still have vertical and horizontal velocity, but this time it's called Vx for the horizontal and Vy for the vertical velocity. Now, this red line represents the path. It doesn't represent the velocity, but there will be a resultant velocity vector, which represents the combination of the vertical and horizontal velocities. So the resultant vector between these two, which will be acting in that direction, will just be the velocity, the overall velocity. But when we're dealing with the horizontal and vertical components, it's Vy and Vx. Okay, so that's the beginning and at the end of the flight path. Now, if we zoom in and we have a look at what's going on throughout the actual path. So when that ball is first kicked, there is both vertical and horizontal velocity. So what's actually happening? Is the horizontal velocity changing at all? So the horizontal velocity doesn't actually change throughout the whole process of the ball being kicked. So all the way from the start to the end, that Vx and Ux are going to be equal. Okay. Now that kind of makes sense when you think about it because there's no force if we ignore air resistance and we ignore drag. There is no force acting in the horizontal direction. In the vertical direction, there is. So that's why the Vx is equal to Ux. It's because there's no other force pushing this way or pushing this way when we think about it like this. So the initial velocity is equal to the final velocity. Now, Vy is a little bit different to Uy. Okay, so you'll see there's lots of formulas in your formula book that describe the relationship between these different things. So Vy and Uy, they are different. So you can see that Vy squared is equal to Uy squared plus 2GSY. That's in your formula book. That's one of the equations. And they're all to do with projectile motion. All right. And also, an important thing to remember is at the height or the top of the parabolic path, so at this part here, the vertical velocity is actually going to be zero. So Vy is equal to zero at this top point because there's a point where the ball stops going up and there's a point here where and then it starts falling, which means that exactly halfway throughout the flight path, Vy is going to be equal to 0. Okay, so that can help you with some questions as well. All right. Okay, so you'll see all those different formulas in your formula book, and they tell you the relationship between these different variables. So Sy and Sx, which is what we've got written down on the side here, they are the horizontal and vertical displacement. Okay, so again, you have displacement height and also horizontal displacement as well. Okay, what else is there? There is time, obviously t is time and g is gravity. So practice using those equations for when you're talking about horizontal motion, projectile motion, and breaking it down into the horizontal and vertical components. Hopefully that makes a little bit of sense.